Strings are sequences of characters. Just like in Java, you include the string heading the library there to use them. In a lot of ways, they're the same as Java. A lot of the things you're used to, but there are important differences that I want to talk about with you today. So the indexes are the same. They start at 0. You can access individual characters using array type notation with brackets. That's fine. You can concatenate strings with plus. You can have string s1 is mar, and you could add a ty on the end, and now you have marty. I mentioned this last time. There are a few things that C++ can do with strings that Java cannot do. So for example, you can actually ask whether a string is greater than another string. What you're actually asking is which one comes later in alphabetical order. That one is the greater one. And that's case sensitive. So anyway, you can't do that in Java. In Java, you have to use this method called compare_to if you want to know which string comes before the other. You can also ask whether strings are equal or not equal to each other to compare them for equality. In Java, you have to use the .equals method, EQUALS. You have to spell it out. So that's a little nice. C++ allows us to do that. I don't want to go into it very much, but the reason C++ lets us do that and Java doesn't is because C++ has this interesting feature called operator overloading. And I don't really want to go into that right now, but we'll come back to that at some point. So anyway, another thing that I didn't really get to last time about C++ strings is that they can be modified. Like you can call a method like append, and that will add new letters onto the end of a string. Kind of like plus equals does, basically the same thing. And you might say, well, you can add things on a string in Java as well, but there is a really important difference. In Java, if you want to modify a string, like here's me in Java, and I say string s, this is Java code, string s equals Marty. If I want to modify s, if I want to, like there's a method here for C++ called erase, you want to remove letters or you want to append letters, you wouldn't be able to just say s.append, step. You wouldn't be able to do that. You'd have to say it in a slightly different way. You'd have to say s equals s dot or whatever. Have you ever remember this pattern from A or from Java or other languages where you have to like reassign it back into the same variable for it to modify it? And I mean, that's a little weird when you're first learning to program, but it actually is fairly consistent with the primitive data types. Like if you have an int x equals 5, and then you say x plus 2, that doesn't change x to be 7, right? If you want x to be 7, you have to say x equals x plus 2. So even though that's a little unusual what we did with the string there, it's actually pretty consistent with what you do with the other types, like int, right? In C++, you really can just say append or erase, and it modifies the variable in place. You don't have to say s equals. So that's interesting. OK. Well, here are some of the functions that you can call on strings. The syntax for talking to an object in C++ is the same as in Java. You write the variable name of the object, and then a dot, and then the method you want to call, and you're now talking to that object. So you're asking that string, what is its length, or you're asking if you can find a substring inside of it or delete something or these various other operations. I'm not going to spend a lot of time talking about each one of these functions because I think they're all similar to things you've seen before. And really, it's just a matching of the names, a substitution of the names from Java to here, right? OK? The one function that's a little funny is it's called find if you're looking for a substring. In Java, I think that method's called index of. And if you're looking for a substring inside of a larger string, in Java, I mean, also in C++, but also in Java, that method returns the index that the string here starts at. So if I say find canoe, it'll return the index where the letter K in canoe is found in the original name variable, if it finds that. If it doesn't find canoe in the string, do you know what the method returns in Java? -1, yeah, bless you. In C++, it doesn't return -1. It returns string : npos. What the heck is that? It's just some kind of weird error constant. And so if you try to write -1, your if statement won't work properly. So you have to be a little bit careful about that. But in general, other than that, most of these methods behave ways that you would expect them to behave. Yes, sir?
Kind of a general question. Does C have these I guess the interface that we're using for C++, Is there like a help function where you can search through the body, through the libraries to find functions that do what you want?
Yeah, the question is there like a way for me to just try things or search or get help and just look at the list of available commands? Well, there isn't one really built into C++, but what you can do is if you go to our class webpage, up in the top right, there are some links. These two links are really helpful. There's a C++reference.com and there's a C++.com. And both of those links have nice documentation about different parts of the language. And if you want to look up certain methods or certain objects, you can find them here. And since there's a lot of links here and it can be a little bit overwhelming, I try to post links down here to the various ones that might be relevant to the lecture of the day. So if you want the string methods, there's a link for you. So yes, that's how you look that stuff up. Thanks for that. Any other questions so far? Yeah?
What is the difference between s.find and s.rfind?
Oh, s.find and s.rfind. Rfind means reverse find, find from the back. So it'll find the last occurrence of that substring versus the first occurrence of that substring. Those are only different if that substring occurs more than once in the overall string. Okay, anyway, these are some of the methods that you can call on strings in C++. But now it gets evil. Remember I said last time C++ strings are evil, and I meant it. Let me explain why they're evil. The reason is because there are two kinds of strings in C++. I think I said to you before that C++ is a new language that was based on an old language called C. The old language C had strings, and C++ wanted to have strings as well, but they wanted to have better, bigger, more powerful strings, and the stuff they wanted to add was incompatible with the old way. But they really wanted C++ to be compatible with C, so they didn't want to change the existing kind of strings, so they made a new kind of string, so there's two kind of strings, and they're both in the language, and it's annoying because depending which type of string you're interacting with, the behavior will be different, and the things that you can do are different. And you might say, well, why don't I just pick one and stick with it? And the answer is because you kind of can't, because the other type of string will bleed into your code somewhere. Some other place will send you a string, and it'll be the wrong kind of a string. It's annoying. So I'm going to try to give you the kind of quick version of this and what to look for and how to avoid common pitfalls and how this affects you. So what is the difference between these two kind of strings? Well, it says up on the slide here that the old style of strings from C are technically just arrays of character values in the memory of the computer. That's all they are. You might say, well, isn't that what a string is? Well, kind of, but strings are supposedly like objects, and objects are little buckets, little protected little shells with maybe methods inside of them and data inside of them and all of this. And a C string is not that. A C string is literally just a brick of memory that has characters in it, and that's all. It doesn't provide any functionality or any power. It just stores the data raw. A C++ string is more of a richer, full-featured object. All of the stuff I've been showing you on the previous slides, I was showing you C++ strings. Okay, well, so where do the C strings come in? Why aren't we just going to use the C++ strings? Well, the problem is whenever you put a string in quotation marks, like hi there, technically that is an old style of a string, a C string. Why did they do that? Well, because again, in the old C code, when they put quotes, they were referring to a string, they were referring to a C string, so they can't change what that means in C++. So it's an old style string. And I guess what I'm trying to say is that thing in quotes, that sort of literal string value that you would write, it's not actually a full object, and it doesn't have all the power, all that stuff that I showed you. So for example, bless you. For example, if this was Java code, I'm going to nuke that now because we're going to talk C++. But if I say something like, string s equals Marty, and then I say, what's s.length or something like this, then I should get a 5. That's fine. And being able to do that means that must be a C++ string. It's an object. It has methods. It has a length method. But if you try to do something like, Marty.length, that does not work. It actually provides a syntax error. It doesn't compile. You'd think it would be 5. It's 5 characters and so on. Doesn't work. And it seems like these are the same, aren't they? But what technically happens is when you assign this line right here, this thing on the right is an old style of string, but when you store it into a new style of string variable, it silently converts it into the new style of string, the C++ style. And once that conversion occurs, now you can call all of those methods on it. So this is annoying, the fact that these variables in quotes don't have any of the functionality with them. So that means, this being the case, if you try to say hi plus there, that doesn't work because the plus operation is an operation of C++ strings. And those are not C++ strings yet. They're C strings. So therefore, I mean, isn't this stupid? This is like not useful knowledge, okay? This is like annoying shit that you have to deal with. I got 2 emails from SCPD students. One said, can you please not swear so much? And the other one said, I like how you swear so much. So I'm going to swear exactly the same amount until my dean calls me or something. So look at this. If you say hi plus there, that's illegal. That's an error. It's a compiler error. But if you say string s1 equals hi, and then string s2 equals there, and then you say s1 plus s2, that produces a new C++ style of string whose value is hi there. So the fact that I stored them in variables like that did the conversion, and it made the plus become something that worked after that, which is, it's weird and subtle and it's annoying, but this is a thing you'll encounter when you write code. Yes, sir?
So could you also write string parentheses hi in parentheses plus string parentheses there in parentheses?
Right. So another thing you can do if you don't want to type all these lines, which is cumbersome, you can explicitly force a conversion into the C++ style by writing the word string in front of something. So if you said string parentheses hi plus string parentheses there, it's kind of like a typecast. You're forcing it to convert those into C++ strings. Then it will let you do the plus operation on them. Or even just one of the two being C++ string. If the other one isn't, then the one that is kind of is able to promote the weak one into its type, and it works. As long as one of them is good, then both of them can add together. But if they're both old style, it doesn't work. So anyway, there are ways around this. This isn't going to ruin our lives or anything, but there's just some stuff to watch out for. So there you go. Hi plus there, that works. Or string hi plus there. There's some other funny stuff that happens with strings that is related to the whole C string versus C++ string thing. Here's a funny example. Sometimes you want to convert from strings to numbers or back again. So you say, I've got the string 42, and I want it to be an int of 42. You know, I want to store the number 42 in int n. So I typecast, I cast from string to int. And you know what's funny about that is it's not an error. It lets you do it, and n stores a gibberish, crazy value. It doesn't store the number 42. And the value that it does store is the memory address at which that string is located in the computer's memory while the program is running. Why does it do that? It has something to do with something called pointers that I'm definitely not going to talk about today, but later I'll explain. It's just a dumb thing. This is one of the things you'll find about C++. You probably don't like the compiler in Java very much, right? The compiler is like your mean parents who say no when you ask for candy or a vet or whatever it is that you want. It's always saying no, your code's no good, it doesn't compile, you have to fix it, you have to change it. Your compiler is picky and you probably don't like that. You will miss that a little bit in this class because the C++ compiler is a little more chill. It lets a few things go through, even if they might be faulty, and you'll wish it had told you that you should fix them. So C++ compiler lets this happen. It does a silly thing. It doesn't do what you might have expected it to do. So how do you convert from a string into an int? I'll show you in a second. The way you do it is there's a function that we provide in our Stanford C++ library called string to integer. You pass the string. It could be a C string or a C++ string, and we will return the equivalent int value for you. So that's one way of converting string into a number. There's also an integer to string, and there's also a string to double and double to string for real numbers and that sort of thing. So here are some more things that are kind of funny. That, these are just weird little funny bugs, but I'm showing them to you because a lot of you guys end up writing code that exhibits these same bugs, so I want you to know about them. If you try to concatenate a string with a character, you say hi plus question mark. You notice the single quote marks on the question mark? That means it's a char and not a string. So you would imagine that would all glue together and it would make hi question mark, but you have to be really careful because the storing it as a variable and converting it into the good kind of a string, that doesn't happen until it goes to store it, and it does the plussing before it stores it. So at the moment of the plussing, it's not a C++ string object yet. And so what that actually does is it produces a string of garbage by adding the memory address of the string hi to the integer value of the question mark character and then pointing to that place in memory and converting whatever's there into a string and storing it into an object, which is usually garbage. What the heck are we talking about? C++ is full of weird stuff like this. Same thing if you take hi plus 41. It actually goes to the memory address of the string hi and then moves 41 bytes ahead of that place in the memory, and then whatever text is there, it stores that into string x, which is usually gibberish, or it could be some other output from some other part of your computer. Weird stuff happens when you try to do simple, innocent things like concatenating a string with a character or a number. How do you suppose you would get around this and make a piece of code that does what you wanted it to do? Any guesses? Switch to Java? That's not an option. Oh, if you want to switch languages, though, I do have one other language we could switch to. Instead of C++, we could use my other favorite language. It's called Ook. It's a language that consists entirely of primate calls. And so if you say ook, 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 then it executes these different commands. So like, this is a program that prints hello world on the screen. Ook, 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 ook. Actually, I don't think we should go with this language. The layer hours are really noisy when we use this one. So let's just stick with C++. But anyway, these things don't work. A simple workaround would be just to split the line up a little bit more. If you split the line up by putting the string with parentheses to force the conversion to happen earlier, if you make hi into a C++ string first and then concatenate the question mark, then it will do what you would have thought it would do. That works. The other thing you could do is, this is another thing that's broken, which is if you take a string, even a C++ string, and you try to concatenate an integer, so you might think I would get hi question mark 41 as the string now, but you don't. You get hi question mark parenthesis. Do you have any idea why there would be a silly parenthesis here? I didn't see anything about adding a parenthesis onto a string. Any guesses, any thoughts?
I mean, other than the text that's right there.
I forgot. I answered my own question on the slide. Sorry. I need that to fade in or something. The reason that it adds a parenthesis is because every character has an integer value that it's actually stored as in the computer's memory. It's called an ASCII code. And the parenthesis' little internal number for it is the 41 number. And when you add 41, it actually thinks you're adding the character whose value is 41, which is a parenthesis. So, what a mess. So anyway, there's just a lot of little pitfalls like this that you have to watch out for. So if you want to actually concatenate a 4 and a 1, you convert it into a string first, and then you concatenate it, and it'll do the right thing. But, you know, just got to watch out for these kind of things. You will encounter this from time to time when you write your programs. Okay? You can read strings from the console. You know, we do cout to print things. You can use cin to read by putting arrows into a string variable, and then it'll prompt the user to type a string and read it. But it only reads one word. Like if you look at the example output in my comment there, the user types John Doe, but it only grabs the word John. So if you want a whole line, there's a function that you can call named getLine. And you pass cin and the variable that you want to store the result in. And then when this returns, that variable will store the line that the user typed. So notice how it doesn't return the result? How do you think it's happening that I'm passing this in and then John Doe is getting stored into that? What mechanism is it using? It's a reference parameter. It's passing a reference to a string, and then it's storing their value that they typed into that reference of that string. Yeah, exactly. Good. So we don't usually use that cin arrow style. In this class, in general, you almost always would want to use something else, like getLine or some other command. There's also those other ones I showed you before, like getInteger and getReal and that kind of stuff. OK, so you see my little icon, right? I'm about to ask you a Socrative question. So let's get our distraction devices ready, and let's do that. So I'm going to click, don't read each other's email address. I'm going to click on the quick question, multiple choice. Oh, actually, I think it's on the other, wait, what happened? It's on the other deck of slides I want to go to. So lecture 3. Okay, here you go. Here's a piece of code that has a mystery method that you pass in some strings and it does some things to change them. And then I print some output down here. So tell me which of those 5 choices on the right do you think is the output from this program? Go ahead and take a look. I'll give you a minute or two. Please feel free to speak to someone around you if you would like. Let's do about 15 more seconds, then we'll show some votes. If you haven't voted yet, give me your best guess so I can record your vote, and then let's take a look. Ready? Here goes. Wow, okay, lots of you think the answer is D, which is Marty Stefupa. Okay, so some of the answers have Artie and some of them have Marty. How do you know that it's Marty and not Artie? That would, be the deleting of the M here, right? How do you know the M stays?
It's passed by value.
It's not passed by reference, it's passed by value, so even though I changed it, it made a copy of the string when I passed it. So it doesn't affect back in the main function, right? So the M does not stay deleted, even though I deleted it up here. And then this one's by reference, so adding the last character of A onto the end of step gives me stepa. But then I insert at 3, I insert a foo, so I get stefupa. So yeah, I think D is the right answer. Does that make sense to you guys? So, okay. Anyway, any question about string before I move on to another thing for a few minutes? That's kind of the basics of strings, yeah.
So in B dot insert 3 and foo, so foo is a C++ string?
Oh, right. Her question is, when I wrote foo there, isn't foo a C string or is it a C++ string? What you find is that there's a lot of methods that take a C++ string as a parameter. If you pass a C string in for that parameter, at that instant that it gets passed, it converts that into a C++ string. So for that piece of code, if I'd written string foo or just foo, those would both have done the same thing. Yeah, that's a good question, though. I think in general, you don't have to think about C string versus C++ string too much, but just there's a few of those cases like on the slides where you want to avoid certain types of code that lead to common pitfalls.